I've got an excellent video for you today. We're going to be taking a look at a bunch of different radiators to decide which one I'm going to be using in my overall testing process. This video was made possible thanks to viewers like you hitting that subscribe button and joining me here on Computer Tech and More, as well as my Patreon members and my YouTube members that are basically helping fund this channel. So thank you to each and every one of you who has both supported me as a YouTube member or as a Patreon, or by just simply joining me and viewing the videos, because YouTube is finally helping me out a little bit. So I bought 3 different ones to kind of test out. We got the Corsair XR5 140mm class, the EK Quantum Surface, and I actually got this and had it in testing before the whole EK thing kind of blew up around it. So, I mean, if their product is good, it still might be worth considering, but just note that it's not me saying, hey, I like EK at the moment. And the Nemesis Black Ice Advanced Radiator Nemesis 140 GTX. So I chose 140mm class radiator because I want to be able to use it with both 120 and 140 millimeter fans, so that I can just have a standardized radiator that I use for it. Just a single slot radiator, so that I'm testing one fan in a pull configuration or in a push configuration on it, just to check thermal loading. It's not going to be on a top tier type system, so I'm looking for that kind of thing. I really wasn't looking at getting a double fan type radiator. So let's take a look at the specs. Okay, let's take a look at the specs of each of these radiators. So we got the Black Ice Nemesis. It is 140mm GTX, that is its naming, $60. It is 172mm by 153mm by 54mm. It's got a fin density of 16 fins per inch. It has a rated wattage capacity of 550 watts. That's just what they have listed. And its warranty is a limited lifetime. We got the EK Quantum Surface S140. Its price tag is around $77. It is 185mm by 145 by 30, and its fins per inch is 20, making it more restrictive even though it's much thinner. Then we have the Corsair Hydro X XR5 140, and its price tag is $45, and it is 170 by 140 by 30 at 16 fins per inch. 3-year warranty. Okay, now that we've taken a look at the specs, let's actually visually take a look at each of the radiators. So the boxes have, you know, some information, the sizes and stuff like that. All this can be found online, so I'm not really going to go and get into it. Obviously, these boxes are empty because I've already done my testing. So the first one is a Corsair, and why the Corsair? Because it's a standard brand, easy to work with, they're well known, well established, pretty standard thickness. It was 30mm thick, so I guess that might be not too thick, but on the thicker side. I've actually never built a custom loop, so right now, I should have said this earlier, I'm just doing airflow testing through it. I'm not buying the pump. I'm not buying the water block. That's going to have to come later as I reach the next monetary milestones. So I'm just running air through it. So it's going to be a step-by-step process. So, you know, it's a standard brand, pretty standard thicknesses as we saw before, and it comes with screws and that kind of stuff. Use them for testing, and overall just, you know, looks like a rad. The next one is the EK Quantum. It's another, I believe, 30mm class radiator, and I must say it is a nice looking radiator. The metal accents on it, having 2 different color metals on it, really does make it look a heck of a lot nicer than the Corsair, despite them being, you know, effectively the same thickness, and even the fin, like the height of the fins inside there, look about the same. We saw that this one has a little bit higher density. The what these ribs right here, that's where the water goes through, look a little bit thicker than what we see on the Corsair. And well, I don't know, having the ribs closer with these fins kind of tighter space between should allow for more heat to dissipate into it. So it has a higher cooling potential than the Corsair one because of just like surface area. Other than that, I mean, it's a radiator. It has plugs. It has, you know, plug-in tubing. You can tell my ignorance as a custom and not building custom builds. And the last one is the Black Ice Nemesis, and this one is freaking thick. So this part is 55 millimeters approximately, and this part is, was it 47 millimeters? I'm gonna get that. Yeah, 47 millimeters. So the height has a new thick radiator, and so this is very much in line with that. So having that thicker radiator again increases that surface area so that it can absorb more heat to allow me to use like a higher wattage CPU on it potentially. So this is the one that I probably end up choosing. It has a little bit of a rattle inside of it. It's got the fin design is very similar to that of the Corsair. I don't know how well it'll show up on camera. Let's see. So you can see how the fins are laid out as opposed to the EK, which are laid out in a little bit different pattern. So yeah, let's go ahead and do the testing. So now, how did each of these radiators do in performance testing versus my Noctua U12A with this blue line? Well, very similarly, this fan was the EK Loop FTP 140, and you can see that some of the values, like the XR5, are underneath it. The Nemesis actually came over top of it, but overall, they're lining up near an identical per RPM for airspeed through this radiator. How about for the P14 Max? Well, here's the U12A again in that blue. So the Nemesis lined up very closely, actually slightly underneath. The other ones kind of were over top, which indicates that it had an easier time pushing through them than my Noctua U12A. The X2GP14 is the stock fan that comes in the Fractal Design Torrent, and it had a much easier time blowing air through all the radiators than it did my air cooler. Okay. Then we have the A12X25 with the adapter, and all the radiators, or it had an easier time blowing through all the radiators except for the Nemesis, which lined up most closely with the Noctua U12A. The Cougar CFV12HP, well, this one, it had an easier time blowing through the air cooler, the U12A, than all the radiators, where it had the hardest time blowing through the Nemesis. And the Noctua NFF12, where it had an easier time blowing through the radiators in general than it did the air cooler. So these results are not particularly consistent and were not what I expected them to be. So I actually want to talk about this for a couple minutes. So we can see from all of this that the fan could basically blow through the radiators despite its extra thickness, extra higher fin density, almost as easily, potentially as easily we could say, as blowing through an air cooler. Now, what cannot be said is how much extra power had to be put into the fan motor to maintain a reasonable RPM. So the more resistance you have in front of the fan, the harder the motor has to work to blow through it at a particular PW fan signal. So if the motor isn't strong enough, the RPM would actually be lower at that particular PW fan signal. While in other cases, it could actually add more power to it to then keep the fan speed at the proper RPM. We can see here that the RPMs don't quite line up for each of the data points. They're actually a little bit lower on the radiators for most of these fans. So not all of them. Actually, let's check real quick. A little bit lower, but very similar on a number of them, but not all of them. So this holds to my statement to be kind of accurate, where it is creating extra resistance, but the net result doesn't actually affect the airspeed in a measurable manner. Obviously, we're not going to be able to compare a air cooler and a radiator truly apples to apples for how effective it is at cooling the system. So I just hope to have an extra test in the future. Okay, now that all that is said, here's the raw data. I ran 6 fans because these are the fans that I had accessible at time for this testing. So 3 140s and 3 120s. The 3 120s were using an adapter plate to allow them to blow through the radiator. Again, right now I don't have a water block or anything to do hardline water cooling, or actually not even hardline, like any like custom loop water cooling. So this is purely airspeed just as a baseline measurement to add to my testing. As this channel grows, I hope to acquire a test system, better equipment, that I can build a couple thermal type systems so that I can actually do heat loads as well as airspeed loads, so I can just have kind of all that best data for you. So right now this is a limitation with this channel. So walking what we have the P-down fan signal, the RPM, and the airspeed going through it. And then I have a percent difference. So the percent difference is the value here minus the value of the air cooler divided by the value of the air cooler. So if this value is bigger than that value, it'll be a positive number, indicating that it had more performance going through that radiator than the air cooler. If it's a negative number, it had less performance by that percentage than the air cooler. And doing it this way takes out the units, so it should be a unitless value if I recall correctly. So we can see how each of the fans performed with respect to each other and whether it had an easier time with each of the radiators as opposed to one of the others. And well, the F2GP14 really had an easy time compared to most of the other fans, which is kind of funny. But that's how I came up with like the decision. It helped me with the deciding process of which of the radiators to actually go ahead and purchase. So now that all that testing is said and done, which one am I actually going to go with? The Nemesis basically won. The EK is $77. The Corsair was $45, $55. The Nemesis was $55 when I bought it. And this has more thermal mass, going to absorb heat better. I can potentially use a higher end CPU. We did see that the airflow going through it was basically equivalent across all of these, but with a thicker, more resistance. It should have a high resistance despite the higher fin density on this one, which would be very resistant to air passing through it. I just felt like the Nemesis would do a little bit better job overall of indicating a restricted airflow. And, well, I am going to create a poll to see if what my opinion is matches up with your guys. Hopefully some like custom water block builders actually like view this video and give me their input, because I had one of you guys actually reach out to me probably several months ago being like, hey, you may want to consider this if you're looking at a radiator. So that's why I ended up picking that one. At least right now I'm thinking picking this one. Because I want high resistance, and even though really didn't see any airflow difference between this and the way I'm testing it right now with an air cooler, it'll allow for different heat loads when I get around to doing heat testing eventually as this channel grows a little bit. I can still add that push-pull, and then so you guys who like building custom systems or using AAOs will have some extra data points, because there was a little bit of difference between using one of these versus the air cooler. Anyways, again, this purchase of getting one of these is made possible thanks to viewers like you and my Patreon and YouTube members. You guys rock. I know I'm a small channel. I appreciate each and every one of you who has helped me out, especially you guys who have helped me grow and work on my videos to make them overall better. So I hope I'm nurturing a good community. Anyways, thank you very much. Have a great day, and I hope to see you next time here on Computer Tech and More.